We are continuing in 2.3, functions and relations. This was the previous video, if you're following this in order. Went ahead and jumped to here. So write down the title, Graphs of Functions and Relations, and draw in 4 different coordinate systems as I did here. So we'll write different functions in there and we'll talk about what they mean. So first one, let's draw in a circle and use a something that's almost perfect, huh? Close enough. Okay, so a circle. And let's go and draw in all the graphs. We'll do a circle, and then we'll do a parabola. Like this. Doesn't have to be perfectly drawn, but to scale or anything, just draw. And the parabola like this needs to be symmetric, but don't worry about that. Do the parabola on its side. Didn't mean to do that. So it would look like that. And then this is the square root function, just like that. Okay, so I'll write down the equations. Let's just suppose this equation is x squared plus y squared equal to a squared. Then this value here would be a negative a, and a. Okay, so is this a function or not? And we can see that if you take a point, so some correspondence, a point on the x-axis like that, we'll call that point, let's just say B. So that point B, what does that correspond to? Well, it actually corresponds to both this value, whatever that value is, and it also corresponds to one below it. We can go ahead and move it to the side there. And it corresponds to the same negative value over here. So your B is corresponding to both C and D. We'll just call them those values. So we have B corresponding to 2 different things. So both C and D in that case. So does that define a function? Is a circle a function? So no, it's not a function. Of course not. So not a function. Okay, we call it a relation. So relation, I'll just say yes. So yes, it's called a relation. It doesn't really matter about relation other than it's not a function. Okay, so we mostly want to determine whether it's a function or not because so many things follow from the content being a function. Okay, next one. Let's look at this one over here. This is a parabola. This equation we'll just say is y equal to x squared. Okay, and so we'll use actual numbers in this case. So let's take a look. So if I put in, say, 2 and negative 2, what do those values correspond to? So you can also use function notation, but when you square 2 or negative 2, what does that correspond to? It corresponds to 4. Yes, because you square both of those and you get 4. Does that define a function? You can see every value is going to be like that, right? You have 2 different values corresponding to the same thing. Is that okay? So this corresponds to this, and this corresponds to this. And yes, that's okay. That corresponds to 4. I don't know if it really is 1, 2, 3, close enough. It does correspond to the same thing. That's okay. Because what you don't want to have is 2 corresponding to, say, this one and another one down here. Okay, so this is yes, a function. So yes, a function. Okay, next one. Let's go down here. So is this a function? So remember, this is your domain. This is your range. Does this graph define a function? The equation of this we'll say is x. Actually, I didn't really want to use that color. You wait just 1 second. Hold on. Okay, here we go. This is x equal to y squared. So is this a function of x, is what we say. So how we describe this, and this one is not. You can see that if you put in a value, say 4, it's corresponding to basically -2 and 2. So 4 corresponds to 2 different things, 2 and -2. So what we say then is this is not a function of x. Okay, so no is the answer. So not a function. So that's -2. This is +2, not a function. Now, what we have then, basically when you solve this, is you end up getting y is equal to plus or minus the square root of x. And so here's your top portion, here's your bottom portion. So this function, if you just take one of them, y equal to root x, then you do get a function. So you take any value in here, x1, and it corresponds to just one value, y1. So that's okay. That's what we want. Okay.